In this video, I'll show you how I built a CoreXY 3D printer with a 300 by 300 by 400 mm build area using two old bed-slingers, Creality CR10S and CR10 V2. And no, this isn't clickbait. This entire project in this version cost me less than $200. Hi everyone. Right from the start, I want to answer a question that viewers often ask. Why go through all this effort and trouble when you can just add some money and buy a decent ready-made printer? For me, the explanation is simple. I like 3D printers more than I like 3D printing. I enjoy working with printers, building them, fixing them, modifying them, and adding new features. It may sound strange, but I even enjoy setting up firmware. And if all of this feels boring to you, then printer building projects are not for you. It's easier to just buy something ready-made. But for everyone who understands me, here is the story. Almost right after releasing my first video about the Duender project, where I built a fast CoreXY printer out of two old Ender-3, I started getting comments like, can it be made from two other printers, not Enders? And is it possible to build it from two different printers? In the last few months, I've been checking local marketplaces for old and broken 3D printers, and most of the time I found listings where people were selling old but working printers for surprisingly high prices. But if an old printer has a problem, the price drops a lot. Some people don't know how to fix it, others don't want to waste time on it, and some just bought a bumble up and realized they enjoy printing more than fixing printers. That's how I found an old Creality CR10S for sale with the Marlin E1 error, priced a little over $80. Usually this error just means you need to change the thermistor or heater. It's a small fix. After some bargaining, I bought the printer for only $65. I fixed it, put my old Duender extruder on it, added a proper control board. I even made a diagonal braces out of old speaker stands. There were some issues with the power since the first CR10s run on 12 volts. I had to use a separate power supply for the bed, but the printer did work for a while, not fast but decent. Then one day Facebook Marketplace notified me that one of the printers I was watching dropped in price. Someone was trying to sell a broken CR10 V2 with a bunch of upgrade parts for $180. But apparently no one wanted it, and he lowered the price to $60. The next day, I bought the printer. It turned out to be one of those cases where someone tried to upgrade their old printer, but eventually gave up and bought a bumble up. As a result, I not only got a complete printer, but also a pile of extra parts, including a BIGTREETECH SKR 1.4 turbo board with the TMC 2209 drivers, and even Raspberry Pi 3B+. On top of that, there were lots of spare parts for extruder, fans, a few displays, and other bits and pieces. It may seem like I just got very lucky with these deals, and that it's hard to find people willing to sell their printers so cheap. But it turned out this happens quite often. Many makers know how many problems old printers can have, so they just want to get rid of them and free up space in their workshop for printers that simply work. On my Discord server, I often see people buying old bed-slingers for $50–60, and it's not rare. By the way, join my Discord server. There are already lots of smart and friendly people there. You'll find the links in the description. Also, if you want and are able to support the channel financially, there are links to Patreon and regular donations. Huge thanks to everyone already supporting the channel. This project exists because of your help. Alright, enough backstory. By this point, I was sure I would build a big Duender out of these two printers. I still haven't decided what to call it. For now, I named the project DuCR10 S2. The name is similar to Duender and S2 stands for CR10 S and V2. But this name is awkward. It's not even clear how to pronounce it. So I'll just call it S2. Write in the comments what name you think would fit this project better. The first thing I did was completely disassemble both printers to see what parts I had. The idea was simple. I wanted to stay as close as possible to the concept of the original Duender, use as many parts from the original printers as possible, and buy only what really needed. In any case, I had to buy some brackets and motion parts. I ordered a set of corner brackets for the frame, a pack of 10 idlers, a 5-meter GT2 belt, and 2 sets of M3 screws, short and long. And that's when the fun part began. I had to figure out how to combine profiles from 2 different printers into one CoreXY frame. And not just any frame, but one that would let me reuse some Duender parts without changing them. The first thing I found out was that even though the printers look very similar and both have 300 by 300 by 400 build area, all the 2040 profiles from the CR10 V2 were slightly longer. On top of that, the CR10 V2 bed profile had a very inconvenient cutout. After a few attempts to put things together, it quickly became clear that for proper symmetry, I would have to shorten those profiles. I did it with the old hand saw, which is far from the best tool for cutting aluminum straight, but I did what I could. The result wasn't perfect, but acceptable. I also shortened the profiles with the cutout, so that the wheels could roll smoothly along its full length. The matching profile from the CR10S had to be cut to the same length as well. In the end, after several tries, I ended up with something like this. The CR10 doesn't have 4040 profiles, so the base of the frame was lower, built from two 2040 profiles and 2020 crossbars. That could have caused problems with the Z-axis motors, but the CR10 has rubber feet, which solved this issue. Also, the profiles stick out a bit on one side, you'll see later why. The CR10's Z-axis profiles became the corner posts, just like in the original project. The top part, the XY section, turned out to fit almost perfectly with the original Duender parts. They were the CR10 Y-axis profiles. They are also a bit longer than needed, but that wasn't a problem. The main thing was making them the same length. The front belt tensioners fit with no issues. At the back, I had to improvise a little. I really wanted the motor mounts to be fixed at all 3 points. I didn't have a single long enough 2020 profile to place it like in the original. So I built this interesting structure by joining two 2020 profiles with metal plates. By the way, those plates also came with the printers. They were used to mount the CR10's rubber feet. The outer profile ended up too short, so I attached it to the mount using a small spacer. For the Y-axis carriages, I needed aluminum plates. I already had them from the first versions of the Duender, and they fit without changes. However, the profile was slightly longer than needed and pressed against the plastic parts. I decided not to cut it and instead adjusted the model so the plastic wouldn't get in the way. For the motion system in this version, I used idlers with the 0.5mm metal spacer washers. They can be stuck to get the needed spacing between idlers and frame parts. It's a bit inconvenient to do this in the belt tensioners, though still possible. The only change I made for the XY parts was at the back near the motor, where I had used large bearing before. I modified the holes to fit idlers with the M5 bore. This came from one of the printer's Y-axis. And now the most interesting part, the Z-axis. This is where I run into the most trouble. At first I hoped to make it neat with the 3 Z motors and real leveling. But it turned out that since the CR10S Z-axis is much larger than X and Y, all 2020 profiles too short to serve as Z guides. So for the Z-axis I used two 2040 profiles from the base of one of the printers that I hadn't used yet. Maybe when I switch to linear rails, I'll try the idea with the 3Z motors, but for now I installed two motors with the two 2040 profiles. They were too short to reach the bottom mounting point. I came up with the idea to use two remaining 2020 profiles to mount the Z-axis guides higher. Because of the length of these 2020 profiles, I had to shift the corner posts a bit. The result was solid, and as I later found out, this configuration actually gave me the full 400mm on the Z-axis. The Z-axis parts had to be modified, of course. On the motor mounts, I removed the extra pieces. The top mount I made wider to fit the 2040 profile, and made the same mount for the bottom. I also adjusted the bed mounts so the wheel could run on a 2040 profile, and the mounts would fit at 300 by 300 mm bed. I needed 2 new aluminum plates for the Z-axis carriages, so I made them. The cuts were fine, but I messed up a bit with the drilling. Because of that, I had to screw the back leveling screws out a lot and tighten the front ones almost fully. Strangely, even with the crooked mounts, the Z-axis still moved smoothly. But after a while I got tired of it, so I re-drilled the holes a bit and aligned the mounts. Now about the extruder. Back on the CR10S I had installed my old Duender extruder. It built from a motor and gears taken from an old BQ H2 paired with the Bambulap X1 hot end. To mount it, I slightly modified the original carriage, printed a small spacer to cover the protruding parts, and drilled holes to match my extruder. For the belt mounts, I cut slots by drilling a few holes and connecting them with the file. The old belt mounts were on the way, so I bent them aside a bit. You could also just cut them off. This version of the extruder is far from perfect. That's why at some point I changed it to one with the regular sharp gears. Also, my best bamboo hot end, or rather its clone, is now on the first Duender, and I'm not planning to take it off. I already ordered a new one for this printer. For now though, I'm stuck using a heavily worn and damaged hot end. So the extruder at this stage is not great, and in tests it sometimes causes defects. And by the way, when I say the whole project cost me less than $200, I include the extruder parts in the total. As for wiring and firmware setup, I won't go into detail. I already have 4 videos about installing and setting up Clipper, and nobody watched them. In short, along with the CR10 V2, I got a BIGTREETECH SKR 1.4 turbo board with the 5 TMC2209 drivers. It's a decent board, not the best in the world, but it has almost all ports and protocols needed. For the Clipper host, I also got an old Raspberry Pi 3B+. Clipper should normally run fine on it. I used it for years on a similar board. But this time, for some reason, the Raspberry wasn't stable and would randomly freeze mid-print without errors and log entries. I tried all power supplies, all USB cables, all SD cards. One theory is that the latest mainsail OS images have become too heavy for the old Pi3. Maybe installing a 32-bit system would help, since people say it's lighter for old Raspberry, but I didn't try that. In the end, I just got tired of fighting with it and switched to my BIGTREETECH CB1 with the PI4B adapter, which I had used on the Duender before installing the Manta board. And like magic, with the CB1 I had no problems or errors at all. Yes, it doesn't quite fit the concept of this video, but I simply didn't have time to dig into this issue any further. I'm sure if this isn't just my case, a solution will show up online soon. As for the Clipper configuration, I basically just adapted the config from my first Duender. I changed the pin assignments for the new board, adjusted the axis min and max positions, tweaked some coordinates in the macros, and fine-tuned the calibration parameters during testing. If anyone wants to take a closer look, I leave a link to my config in the description. On the electrical side, the CR10 V2, unlike the 10S, already runs on 24 volts. Its power supply a decent Minwell 24-volt 350 watts unit. Sure, it's not very powerful, the bed heats slowly, but it can still reach 100 degrees without any enclosure. Of course, I used the bed from the V2. The wiring turned out to be kind of interesting. In the first CR10 generations, the control box was external, so all the cables had quick connectors, and the printers had extra breakout boards. Ideally, I should make new wires of the right length with the proper crimped connectors, but that's something for later. For now, I used whatever cables I had. The funny part is that I even reused one of the breakout boards to connect the XY motors and extruder. The electronics box is temporary, so the connectors are hanging outside, but with some tweaks it could look pretty neat. And finally, the most interesting part. What did I actually end up with? The build volume stayed the same, 300 by 300 by 400 mm. Plus, at the front of the Y-axis, there is extra space that can be used for the cleaning brush or porch bucket. Like I said before, the extruder I'm using now isn't great, and it causes small print defects. It doesn't make sense to judge the printer by this extruder's performance, since I will replace it soon. But even with this setup, I was able to print up to 18 cubic millimeters per second with the regular PLA, not even high flow PLA. It could probably do more. With the fresh Bambulab clone hot end on the Duender, I managed to push it to 30 cubic millimeters per second. Overall, just like on the Duender, I could put something like Stealth Burner or XOL, but thanks to the IKEA effect, I still haven't convinced myself to move away from my own extruder design. And now the most interesting part, input shaping. I measured it with the simple ADXL 345. I didn't mount it in the best spot. Ideally it should be as close to the nozzle as possible, but for the general picture this should be good enough. I ran the tests with the default resonance tester settings. I didn't lower the frequency range, didn't change axle per Hertz, and didn't disable axis movement during the test. Everything was left at default. The results weren't amazing, but still acceptable. For the x-axis, things looks fine. There was only one resonance peak, which is good. The peak frequency was about 53-55 Hz. That's fairly low, but still workable. Clipper recommended using the MCV shaper at 55.4 Hz, with the max accelerations up to 9000 mm per second square. It should cancel vibrations completely, and smoothing is not strong. But on the graph we can see some small leftover vibrations after the main peak. It seems MZV hits the most difficult spots, so it should work well. If it doesn't, I could switch to the more aggressive EI shaper. The y-axis wasn't as good. Besides the main peak, at about 40-45 Hz, there was another smaller resonance. The recommended shaper here was also MZV with the max accelerations of 5700, but if you look at the MZV shaper curve, its first main wave overlaps the first peak, while the second peak isn't fully suppressed. The EI shaper, on the other hand, covered the whole resonance range. Yes, its recommended accelerations is a bit lower, but the important thing is avoiding print defects from vibrations. The smoothing isn't great either, but that's expected. The lower the resonance frequency, the stronger the smoothing effect when accelerations goes up. At some point I even used diagonal braces from the CR10 V2 to install them on the sides and make the frame a bit stronger. Honestly, it didn't help much. Of course, I was hoping for better results. One of the very first Duender versions already showed accelerations above 10k, even on the y-axis. But for the printer with this build volume made from old parts with the total budget under $200, a real 5k accelerations is actually a decent result. And now let me show a few print examples. The Orca cube came out almost perfect. There were some small defects, but nothing serious. Okay, I'm joking. This cube was printed on a quickly assembled printer before any calibrations and test. And here is the cube that was printed after all the checks and tuning, almost twice as fast as the first one. The print settings were copied from the default Bambulab P1P profile, 10k accelerations for inside, 5k for outside, and speeds from 200 to 300 mm per second. I was also curious to see how the printer handles vertical fine artifacts, so I printed the standard VFA test from 40 to 200 mm per second. No miracle, the artifacts are visible. They mainly showed up between 80 and 130 mm per second. At slower and faster speeds, things looks much better. Considering the speeds this S2 can print at, that's enough to avoid the problematic range without issue. The next is small art model, but it turned out so well that I really wanted to show it. A small cat. Apart from some light stringing caused by extruder problems, the model came out nearly perfect. I can't find a single major defect on it. But we all know that two main tasks this printer should handle are printing wide parts that take up the whole bed and printing tall parts that use the full Z-axis. To test the Z-axis without wasting lots of filament and time, the easiest way is to print something in vase mode. To make sure the vase wouldn't be too fragile, I used a 0.8 mm nozzle. At the same time, I decided to try the fuzzy painting function. It has been in Prusa Slicer for a while and recently appeared in the alpha version of Orca. I made the base 400mm tall, and it turned out pretty good. Toward the top, on the side, there was some strange defects. At first, I thought it was swaying at that height, but the other sides are clean, and the defects look more like a software bug or the G-code glitch. The most important thing, though, is that there is no noticeable Z-wobble. To double check, I also printed a simple 400mm cylinder with a standard 0.4mm nozzle. And as you can see, everything is fine. The Z-axis moves smoothly along its full height. For a full bed test, I decided to print a panel from the honeycomb storage wall. I used PETG. As expected, I had some stringing, but aside from that, the model printed well. The first layer went down fine. There were a couple of spots where it printed slightly too high, but nothing critical. By the way, the bed itself isn't perfectly flat, but the leveling error is just over 0.2mm, which I think is more than acceptable for this print area. And to test the printer's stability while also tidying up one of my drawers, I finally got around to Gridfinity. I printed several large frames to fill the drawer space and about a dozen small boxes for parts, using leftover PLA in different colors. A few prints stopped because the Raspberry Pi froze, but most finished successfully. The quality was pretty good too, aside from some stringing. Alright, I think it's time to give some conclusions. Being objective about my own project is difficult, but I'll try. In this version, it's hard to call this printer outstanding, super fast, or especially convenient. But considering the build volume, the parts it's made from, and the total cost, its performance is actually pretty good. Real 5K accelerations, working speeds up to 300-400mm per second, pretty good print quality. I hope you all understand that this version of the printer is not final goal of the project. It's just the first version, built on the minimal budget, made specifically for this video. Of course, I'll keep improving it step by step. The frame needs to be reinforced in every possible way. A proper extruder needs to be installed. Of course, I'd like to switch the whole printer to linear rails. Yes, it wouldn't be a super budget CoreXY anymore, but I'm almost sure that with those upgrades, it could compete in speed with the modern printers like Creality K1 Max. I'm sure there will be a lot of questions about tool changers, IDEX, and multicolor printing. With IDEX, the answer is simple. In this setup, adding a second printhead would mean losing a lot of the build area along the x-axis. As for a tool changer, yes, in theory several extruders could fit, but instead of building a whole bunch of full extruders, I'd rather wait for the Bondtech Index or similar systems to come out. And simple multicolor printing, to be honest, I see less and less point in it. Sure, I could easily adapt and move my Medusa project to the S2. But what for? I rarely print multicolored models. Alright, that's all for today. As always, thanks to everyone who watched until the end, and special thanks to those who support the channel on Patreon and with donations. Thanks to you, I can bring my strange ideas to life. Like, comment, subscribe. That's all for today. See you soon.